We manufacture life-saving equipment. We build products that must work the first time, every time. And our quality policy is we build quality products knowing they are used to save lives. That quality policy is something that we use to make every decision, and we use in the design, the development, the manufacturing process. It really is in the fabric of this entire company, and every employee knows that quality policy by heart and understands how it applies to what they do. We have brought in the most talented engineers that we can, and we've invested in SolidWorks CAD systems and state-of-the-art design and evaluation, simulation software programs and equipment to be able to really design the most reliable products. From a mechanical point of view, we take these three-dimensional drawings, we output them as SLA or SLS prototypes, which are created out of a urethane bath based on a computer drawing without ever having to cut any steel. In 24 hours, I can take a drawing and hand it to an electrical engineer and have him put a prototype board and a prototype GPS receiver in that plastic case, and he can start testing and designing and evaluating the electronics much earlier in the development process than we ever could before. One of the things that a simulator lets us do is you can go back in time at any place on Earth and recreate the exact constellation that is visible to that point on Earth with a simulator. And you can go forward in time and do the same thing. If we wanted to simulate a heavy tree canopy overhead with maybe only 3 or 4 satellites visible on the horizon to the EPIRB or the PLB in that particular scenario, in a simulator I can create that situation. And then, let's say you want to bring in a rainstorm or a snowstorm. We can simulate that too by bringing the signal level down and further attenuating the signal to make it more difficult for the receiver to work. We can test it, bring the beacon out, modify it, bring it back, and reproduce that exact scenario to see if we're making progress. No electronics manufacturer could really claim to be as obsessive about quality as ACR is if it didn't have an extensive test facility, and we've got a great test facility. We can test for shock, we can test for impact resistance, zero atmosphere, vibration, a broad range of temperatures, ultraviolet degradation from the sun, humidity degradation. We can test for salt, exposure to salt fog and the corrosive elements in the marine environment, and all sorts of environmental tests. But what we're really trying to do is make the beacon fail, make the gaskets fail, make the switches fail, make them transmit out of frequency, so we can figure out how to make them better so they won't fail when you need them in real life.